Let's see, participants. Okay, we'll get started here in just a couple of minutes. Okay, it's 12 o'clock noon, so we'll go ahead and get started. So obviously this weekend I'll be covering some of the things you need to know for Project 4. I won't be doing Project 4, but just like I did for Project 2 and 3, I'll give you a lot of useful information that you will need in order to complete Project 4. There's still some GUI stuff in Project 4, but I'm not going to go back through and do any GUI type work. I showed you a good amount of GUI type things for Project 2 and Project 3. So if you need help with if you need help with GUI type stuff, then please go back and review the Project 2 and Project 3 videos. But I will not be doing any kind of GUI today. This is also being recorded, and I will post the link sometime later today. All right, so let's get started. So whenever we look at the write-up for Programming Project 4, one of the first things it talks about you need to do is have an enumerated type named status, and it should contain 3 enumeration literals. Well, I will not be doing that, but I'll be doing a different one. And a little project that I'll be doing today is kind of based on cars and automobiles and stuff like that. You'll have to translate what I'm showing you today and how it applies specifically to your project. So let's create an enum for my project, and we'll call it eCar state. And so instead of a class eCar state, it's going to be an enum. Now, you don't have to have it start with an E. It's just the general consensus that if you have an enum in Java, you start it with an E. Now, it does not say that in the programming project, so make sure you do what the project write-up tells you to do. But if you're just working on your own, generally you prepend enums with an E, just so you know that it is an actual enum. Okay, so what are the different states that a car can be in when you think about it? What are the different things you can do with a car? Let's say a car can be parked. A car can be started. A car can be driving. A car can be, say, stopped at a light. A car can be, that's enough for an example. So this is just saying the different states that a car can be in. And I've defined 4 specific states that my car can be in. My car can be parked, it can be started, it can be driving, and it can be stopped at a light. Now there's lots of more things a car could be doing, but for the example, I'll just keep it with those 4. Okay. So that's our car state. So what can we do with this car state? If we go back to our main, we can have a variable of type eCar state. I'm just going to call it state, and we can assign it a value. It can be one of the eCar state values. So we'll have it as parked. So we have a variable that is of this enum type, and we're setting it to the value parked. Now when we print this out, print ln, let's print state. Down here in my printout, oh, that's left over, but I'm running it. And when we print it out, whenever it compiles, there we go. It says parked because the value of this variable is the enum parked. Now we can call this one of the other ones. We can say it's stopped at a light, right? Let's run that. Stopped at light. And we can change the value later. State equals eCar state dot driving. We can later start driving it. So it should, the initial printout should be stopped at light, and then the next printout should be driving. And there it is. It's stopped at light, and then it's driving. Now, why is this useful over, say, something like a string? We could have like string s equals stopped at light, right? We could have that. It's just not out. Print ln s, right? We could have that, and what that'll do, it'll print stopped at light, it'll print driving, then it'll print stopped at light again, right? But what if we fat fingered it and we left off the L, right? Well, it would print stopped at light, here for the string. And what if we forgot the underscore? What if we accidentally added in extra letters? That's the problem when you use a string versus an enum, is a string can be any value you can type in at the keyboard. An enum is generally when you only want to allow very specific values. And these are the very specific values I'm talking about that I want my car state to be in. So that's why you would use an enum over just a plain type string. Okay? So that's basically all there is to an enum. Okay. Let's look at the next part of your project. Well, let's use this this enum in a class. So let's make a class called car. Right? We'll have a class called car. It'll have a car state in it. This is the state of the car. Okay. Let's make a constructor for our car, and we'll just have the initial state, just like we had in main. The initial state will be, it is parked. That'll be the initial state. Let's do override the toString, and what we'll do for the toString, we'll just say what the state is. So anytime we try to print a car, it's just going to print to us what the state is of the car. That's what the toString does. So let's remove these. Let's make our car. New car. And then let's print out the car. System.out.println car. What Java does behind the scenes is when you print out a variable that's of a type class, it'll use that class's toString method as the string that actually gets printed, right? So when I do a print on a variable car that's of type car, it internally calls its toString method. Okay. So when we print out this car, it should print out what the state of the car is. And in the constructor, we set it to park. Let's run it. And there it is. There's the state of the car is currently parked. All right. Well, car isn't always parked, so let's add a method to change to state, new state. This right here, let's change the state of the car, right? So we'll change, make the state equal to this new state. And so here in our main, we went out to our car and we changed the state of the car to driving. And let's print it out again, see what happens. So what we should have printed out, the constructor makes the car in a parked state. Then we are changing the state to a driving state, and then we're doing the prints with them. So let's run that, and we'll see down here in our printout, the state goes from parked to driving. Okay, so we have this state for our car and a way to change it, right? Let's do another example, and you'll see how it ties in a little bit later. Let's do an example for a computer. The computer state, make it an enum, and the computer can be off or on. We'll just have two simple states for that. Let's make a computer class that has a computer state. Let's make the constructor for it. Its state will initially be off. Let's override the toString for it. The computer state is this state. And we also want to be able to change it. Change state to computer state. It'll be a new state. And then this state equals the new state. So this is almost this is pretty much identical to the car, except that we're doing a computer. And the computer uses a computer state instead of a car state. And this allows us a way to change the states of it. So here we can have the car. We'll change the car state. We can also have a computer. Computer will print the computer. We'll change the state of the computer. This is pretty much the exact same thing as the car. Change the computer to on, and then we'll print the computer again. All right, so let's run this. We should get the printout of the states of the car and the states of the computer. Let's run it. And down here, we have the state is parked, the state is driving, and then we have the computer state is off, and the computer state is on. So that's two examples of how we used this, this enum. One is a computer state enum, and we used it with our computer. And we have this car state enum, and we used it with our car. So that's the example of the enums. So let's talk about the next part you need to know, which is an interface. Okay. So this one's going to be actually really close to what you need to do for your project. So probably giving away a little bit more than I want to, but we'll go with this. But your project says the interface should be a generic interface named state changeable, and it should have a bounded generic type parameter whose type must be an enumerated type. So let's first start off. We're going to bring this back to our computer and car. So let's first start off with making an interface. And we're just going to call state changeable is what it is for the project. We're just going to call it change state. Interface to change state. So instead of, I misspelled it, I forgot the N, but we're just going to leave it off. All right, so it's an interface change state. So what's the difference between an interface and a class? In a class, you're allowed to have variables, and you have methods and the content of those methods, right? With an interface, you do not have any variables, and you have the definition of a method, but not the content. And what I mean by that is, if we have an interface that we want to change a state with, we can have a method called change state, but we don't have the content, meaning we don't have the curly braces to do something here. Nope, we can't do that in an interface. Misspelling's in there, but whatever, it's just a comment. So you don't have the body of a method. You can't do any of the actual work in an interface. All you can do is say what the interface methods are, but not how it does it. So how do we actually get it to do work? Let's fill out the rest of it first, and then we'll see. So the interface should be a generic interface named state changeable. For us, we're doing iChaggy state. It should have a bounded generic type parameter. Stop right there. And that is this. What this represents is that when you have the brace, the T, and the brace, it means this T represents a type. It represents a class type. It represents an enum. It represents a built-in Java class, anything. But we're just saying there is a type, but I'm going to provide it to you later. That's what you as the programmer are saying. There is a type associated with this, but I will provide you that type later. And you can use this down in here, meaning if we have a T state, what this lets us do is whatever this T ends up being, and we'll see how to specify it later, this is going to be that same type T. And so if we have an interface called change state, it defines a method called change state. It's going to use this same type and then the variable name of state. So how do we actually use that? If we look back at our car, we have this method, change the state, this eCar state and new state, and we do the work, right? In the computer, we have change state to, and it's just a little bit different. And we specify this enum, and this is the state. And then we do the work for it, right? Well, what we can do is, so we have this car and this computer where their state can be changed, right? So what we can have is the car can implement this change state interface, and now we have to provide it inside these braces the actual type that we want that to be. And for a car, that would be the car state, right? Let's remove this change state we had before. So the car implements this change state interface, and we want this to be the type, this eCar state. So now in car, this T is going to represent eCar state. We can do the same thing with computer. It can implement change state, except here it's going to be a computer state instead of a car state, right? And we use, when we're using interfaces, we use the implements keyword instead of the extends. The extends keyword is when you want to extend an existing class. Implements is when you want to implement an interface. And when you implement it, you have to provide the definition, or you have to provide the bodies of those methods it says it has. So change state says it has this method, this change state T state. So in car, we have to do that. Override the change state. And there it is. So change state with this generic type T has a method, change state with the generic type T. And when car implements it, it's implementing it with this specific type. And when it does the change state, it does it with this specific type. And then we can do the actual work. Equals that state, right? Same thing with the computer. Is computer is able to change the state with this specific type. We override the change state. We implement the change state with that specific state. We can do the work. So when we go back to main, you know, those were the names of the functions that were specific for that class. Well, now it's whatever the interface was, which is change state. Okay, so let's run that. And we're going to get the same printout, except now we're utilizing this interface to change the state of the car and to change the state of the computer. And you may think, well, we didn't, in this example, we didn't really save any work, did we? Because we still had these methods in there, right? But something it allows you to do is, instead of a car, we can use it, we can represent it as the interface. Instead of the computer, we can represent it as the interface. Because a car does have this interface, I change state. This computer does have this interface, I change state. So we run it, and we'll still get the same printout. But then what you can do with it is, since these are the same type or it's the same interface, and we won't do this too much, we could have a list of these. List equals new array list, right? We have list.add, we can have a new car. We can have list.add a new computer, right? Now, a car is not a computer and a computer is not a car, but they both implement this I change state interface, which is why they can be added into the list that is an I change state interface. And then here we could do a loop and just print them all out for I change state. Let's call it C and list. Is this right for Java? Yeah. System.out.println C. And let's just remove all this stuff up here so we don't get the printout confused with our list. Run it, and we should get whatever the initial state for car, initial state for computer is, and there it is. So that's how you use an interface. Now, of course, you'll need to translate this into what exactly your project is asking you to do, but that's the basic foundation you need to know about how to create an interface and how to utilize an interface when we do the implements. The one additional thing we'll talk about for an interface is, in your directions, it says it should have a bounded generic type parameter, which is what we have. This is the T. And really, this can be any letter. You can make it Q if you wanted. Doesn't matter, whatever letter you want to call that. Just the generic consensus is to use T for type. But it could be any letter. Okay. But it says, so we have a bounded generic type parameter whose type must be an enumerated type. So how does that affect us? So let's take this stuff out of here. So let's have an I change state of type car state, right? Let's call it T, right? Luckily my IDE gives me red squiggly lines when something's wrong. No red squiggly lines, so this is fine, right? We have an I change state for an car state. We could have an I change state for a float. Doesn't complain about that. We can have I change state for a a file, right? And it's fine with that. Why? Because this bracket, T bracket, says it can be any type in Java or any type you create yourself. But our project specifically says the type must be an enumerated type. So what you can do here, we can add in extends enum. That means whatever type this is, it can be any type as long as it's an enum or a subclass of an enum. So go back here to our main, the car state is still fine, and that's because car state is an enum. Float is not okay because float is not an enum. File is not okay because file is not an enum. Now we could change the interface to where the type has to be a number. If we look back in main, now car state is not fine because car state is an enum, it's not a number, but float is okay because float is a number. But in your directions, it says, you know, the type must be an enumerated type. So if you just put an enum in there, that will force this interface type to only be an enum. So the car state works, the float doesn't work, the computer state would work because computer state is an enum. So that's everything about interfaces, about enums, about how to implement interfaces, and that's most of your project right there, apart from the GUI and some database stuff, which I'll talk about the database now. That's all there is to interfaces and enums. Okay, let's switch gears for a second. Like I said at the beginning, I'm not going to do any GUI stuff now. I've done GUI stuff before. You can go back and review those videos if you need help with GUI. The other thing we'll talk about is this database it wants you to put together. Let me find it in here. All right, so reading from your project write-up, the second class should be named project for, and it should contain the main method. In addition, it should contain an instance variable that defines the database of property records, which is implemented as a tree map with the transaction number field as the key and a property object as the value. Okay, so we'll make one change to our car so it helps us do this. We'll have an ID for a car. Let's just call it the VIN. Well, the VIN's numbers and letters, but we'll just call it an ID. All right, it's the ID equals ID. Okay, so now we have a car, and the car has an ID. Probably a unique ID. Maybe it's the VIN or serial number, whatever you want to think about what the ID could be. Okay, and that's just going to help set us up for this database it's saying. So it should contain an instance variable that defines the database, which is implemented as a tree map. So we can have a map with the transaction number field as the key. So a transaction number can be anything. For my example, I'm going to have it be an integer. And a property object as the value. For me, I'm going to use a car as the property object. And they says it's implemented as a tree map. Oh, need to give it a name. Let's call it map. We'll call it DB because it's the database. All right. So this is implementing a database that takes integers and it doesn't convert them to cars, but it allows you to look up a car based on an integer. So how do we add stuff to here? Let's make a new car. And the constructor now takes an ID. Let's just call it 123 as the ID. And let's put it into our database of database.put The first thing we want is an integer key. Let's modify car one more time, and so that we can get its integer value. Get ID, return this .id. So I just made a way for us to get the ID out of the car. All right. So when we're putting into the database, we have to put this integer key we want, and we're going to use the car's ID, and then the actual car itself. Oops. Just call it car. Okay. So now in our database, we at this ID location, which for my example is 123, there's going to be a car. That's the car. Let's print out this tree map. And it's actually a little bit more tricky. Key value integer. You have to give me a second. I and db.keyset. Yeah, that works. And so this is just going to loop through all of the integers in the database keys, and we'll just print out the db.get I. What this does, and I don't even think you need this for your homework, it'll just allow us to see what's in this database. This is a loop through all of the integers in the database's keys. And the keys is this integer. And then we're going to do db.get I. I is one of the integer keys, and the db.get gets me the car. Let's make that more explicit. Car C equals db.get I. And then we'll print the C, so you can understand a little bit better. So we're getting back out of the database this car, and we're printing it out. Okay. Let's modify our car string a little bit. So we don't really care about the state anymore when we're doing this. Let's just print out the ID. All right, so let's run this. So we're making this database. We're creating a car. We're putting the car in the database, and then we're printing out everything in the database. So let's run this. And we get ID 123 because that's the ID of this car put in. We can put in another car. See, car 2. Car, call it with that ID. We create it, we need to put it in the database. Car2.id and car2, right? Let's run it. You get ID 123 and ID 3456. So that's how we're adding stuff into this database. And the good thing is we can do this in a loop. We no longer have to maintain all of these separate instance variables. See, we're maintaining a variable called car throughout the whole main function. We're maintaining a variable car2 throughout the whole main function. Well, we don't have to maintain those. And to show you how, let's just put make a loop from 123 I less than 129 plus I. So we're just going to make some IDs from 123 up to 129, and we'll make a new car out of those. Car with that. Let's make it more explicit. What we're doing is actually it's an ID. Delete all those. And each time we create a car in this loop, we'll add it to the database, right? Car.get ID and then the car. So this is going to run through a loop, create how many ever cars that is, like 6 or 7. It's going to put them all into the database, and then here we'll print out that database again. And the key thing to note, we'll let it print out first, and there they all are. All these cars in the database, right? The key thing to note is we no longer have to maintain a car variable. This car variable only exists within this loop. If we try to do something with it here, it doesn't know what a car is because the car only exists inside here. We have stored all of these car objects we created inside this map, which is actually a tree map. And we're just calling it our database. Okay? So you need to convert that to what's asking you to do for properties. Is it wants you to map a transaction number to a property, right? And so you'll have to figure out what a transaction number is. Is a transaction number an integer? Is a transaction number a string? Whatever the case is, whatever the assignment is asking you for, and you want to map it to a property instead of a car. Well, we mapped it to a car. Okay. So the other things we need to consider. According to your project, your database has to support 3 operations. It has to support insert, delete, and find. So let's talk about each of those. So an insert operation on our database, actually that's what we've already done here. This is the insert when we do the put. That's easy. That's all there is to the insert, is when you have a database and you put one of the items into it. That's the insert. I don't think I need to cover any more about that. Let's talk about delete, though. There's a method, db.remove, and you can remove it by the key, or remove it by the key and the object. So since you have to have the key for both of them, let's just take the easy way and remove it by the key. So what do we want to remove from the database? Actually, let's make this a fewer of them. Let's move stuff around a little bit. We're only going to make like 4 of these cars. We'll print them out. Then we're going to delete one of them, and then we'll print them out again. So which one do we want to delete? Well, you have to specify one of the keys to delete. And our keys are these IDs, 1, 2, 3, 4, 5, yeah. So let's just delete the first one. We'll delete key 1, 2, 3. So what we should get printed out, we should get printed out println, just like a divider, so you know when one database begins and the other ends. So we run this. We have in our database 1, 2, 3, 1, 2, 4, and 1, 2, 5, right? But then we deleted 1, 2, 3, and now we no longer have 1, 2, 3 in our database. All right? We could change this to 1, 2, 4, run it. Same thing, except 1, 2, 4 is missing. And that's fine because we deleted it. Now what happens when we delete something that is not there? Right? There is not a car with ID 111111111 in our database. Let's run it, see what happens. Nothing. Because this didn't exist to delete it, right? I find this bad practice. I think you should verify that something exists before you delete it. Your homework doesn't call for that, but I think it's good practice as you go into a professional career. So let's check if it exists before we delete it. We have if db dot contains key. Well, that's a bunch of ones. Int ID to delete equals, well, whatever. So then we can have, delete it. If the database contains the key ID to delete, then we can safely remove it. db.remove, ID to delete, right? We'll have system.out.println, and we'll just put deleted ID plus ID to delete. Okay, so what we'll do, we'll check, does this ID exist? And if it does, we want to delete it. If it doesn't exist, it just skips over it, right? So when we run this, it should not print out this statement because that ID does not exist, and we don't. So let's change it to an ID that does exist to show you it works. 124 is one of them. Let's run that. And sure enough, we deleted ID 124. I don't think the program project specifies you to check that. I find it very good practice to do so. And in the real world, you'll have to do that. So that's our delete operation. Okay. What is our other operation? Our other operation is find that we have to support. Right? Well, we pretty much did it right here, didn't we? So int ID to find equals 1, 2, 3, 4, 5. If the database contains the ID to find, then let's get the car out of it. Car C equals, what was it, db dot get. And we supply to it the key. And then we'll do system.out.println, and we'll do found ID plus ID to find. And then we can do other stuff with the car that we wanted to do, like fill in other parts of your GUI. So here we're defining which ID we want to find. We're seeing if the database contains that ID. If it does contain the ID, we want to get that car out of it. And then we'll just say that we found it. So if you run this, we'll create the cars, we'll delete one of them, we'll try to find this one, which doesn't exist right now. Actually, let's put an else statement in there so we know it was unable to find it. Unable to find ID to find. All right. So we run this, trying to find ID 1, 2, 3, 4, 5. Of course, it's unable to find ID 1, 2, 3, 4, 5. But if we change it to an ID that does exist, actually, we'll show you 1, 2, 4. Still going to fail because we deleted it right before. We're unable to find ID 1, 2, 4 because we deleted already. But we can find ID 1, 2, 3 because 1, 2, 3 still exists. We found ID 1, 2, 3. And then we could just, and if we wanted to, we could do something with the car. System, we could do like change state. The car state, change it to driving or something, right? So this is the insert into this database. This is how you delete something out of the database. And this is how you find something in the database and then do something with what you found. And that is the main primary things that you need to understand for your project. This is somewhat close to what you need to do for your project. Obviously, this is with a car example instead of the property that you need to do. And of course, I didn't include any GUI. They should be pretty proficient with GUI, as this will be I think the third project with the GUI. So I am now open to any questions you may have about this project or any of the previous ones. And as a reminder, you can turn in any past projects up until the last day of the class. And if you did poorly the first time and you'd like for me to regrade it, it will be subject to the late submission penalty. But if you scored poorly, then you still have potential to do better. I will not accept anything after the last day of the course, which is Tuesday next week. And that's just because I have a very tight timeline to turn around final grades. So if there are any questions you have, feel free to ask them now, this project or any previous one. So I'm at your disposal. If you don't have any questions, feel free to drop off at any time, and I will post this video online and email out the link later.
So I was trying to implement this, and I was originally just doing it all in one file. And when I was trying to create the equivalent to the car file, aka the property, can you hear me?
I'm sorry. Hold on a second, Mark. I see you trying to talk, but I didn't hear anything come out.
Does anyone else hear me?
I can hear you, so okay. I think it's his audio.
Okay, cool, thanks.
Mark, for some reason, I do not see any, or I do not hear any audio coming out for you.
Did you hear, was it Corey? Testing.
Let me see if I need to, I still don't hear. Let me see if I need to adjust any thing on my end. Can you go share one more time?
Can you hear me now?
No, I still don't hear any audio from you. I don't know if it would be something on your side or if others are experiencing the issue. If we can't get your audio figured out, you can always email me directly a question. We could go from there. Oh, they say they I guess hear you, but for some reason I can't. I apologize. I'll try to figure that out, but I'll answer your question if you have a direct chat. So on the rubric, it says that you have to have a parameter whose type is a generic type parameter. Are there anything unique about generic type parameter over just a type parameter? Right. That's what we were talking about when we were talking about this interface, where the T is a generic type parameter. That means T, whenever you are using this interface, the T can be any type. It can be any type that you create, meaning any class that you create. It can be any built-in Java type. Here specifically, I'm reading somebody trying to help me with my audio. Flip microphone button, output speaker. Oh, that's probably why. All right, I may be able to hear you now, but I'll answer your question based off of your text. So the T means it can be any type at all. The extends just means we're limiting it to any kind of enum. So if we take off the enum again, I covered this a little bit earlier. And so we have this I change state. If we go back to main, that means we can have an I change state with any type at all, right? That means whenever we actually do something with the interface, right here we're telling it what type we want it to be. But for the interface itself, it doesn't care. It just means this T can be any type at all. So that's why in main we can have it, we can say we want that type to be a float. We want that type to be a car. We want that type to be a computer. We want that type to be an e-car state, whatever type that we want it to be. And then when we have, like the homework or the project specifically says, we want to have to be an enum, we can put extends an enum. So that means the type it can still be a type as long as it's an enum or it extends an enum. So we can go back to main. So e-car state is okay because it's an enum. Car is no longer okay because car is not an enum. But car state is an enum, or computer state is an enum, so either one works. So your interface is just saying, I don't care what type it is, as long as it's some kind of enum. Nope. Whenever you implement the interface, you have to give it the specific type you want it to be. Here, you are no longer specifying a generic T type. You can't even do that. At this point, when you implement the interface, you have to give it the specific type you want to use. And for our car, we wanted to use the car state. For our computer, we wanted to use the computer state as that type. Okay, so on the chat, it looks like you get that. Okay, so any additional questions? I may have fixed my audio, so feel free to use a microphone and we'll see if it's working.
Can you hear me now?
Oh, yes, I can hear you.
Cool. This is not specific to this project, so if anyone else has project-specific questions, they should feel free to go first. No. Okay. So this is more of a generic thing. I was trying to do this project earlier and was creating a property class in the main file, like a property in my main file. And it was saying that it couldn't create non-static elements in the static file, but when I put it into a new file, it worked. I was trying to parse through in my head what I was doing wrong and was struggling. Does my problem make sense? And if so, could you walk me through why it didn't work?
Yeah. All right. So we'll equate it to kind of what we got here in my main. So let's imagine that I had another class I wanted to create a bicycle. I don't know. But I didn't want to bother creating a new file for it. So it's generally best practice, and I highly encourage it, to put every class in its own individual file. Meaning if I have a bike class, I should make a bike.java file. And then you won't have any issues with what you're talking about. But when you want to put it inside of another class, that's what we call an inner class. And when we have an inner class, let's call it public class bike. And if you try to implement those, it does not like it. You have to make them public static class bike. It's just, I can't say if it's a quirk, but it's just the way Java operates, is that if you have a class inside of another class, it requires this static keyword. It's just the way it is. And if we want to implement this, actually it'd be better if I did it from another location. So let's just say in car. For some reason, the example doesn't make sense. But let's say I have a public class bike. Actually, it needs to be a public static class bike. Let's make a constructor and have it a variable int I. This dot I equals I. Whatever. But so now when I want to use this class, like it's a car.bike, new car.bike, and that's because bike is inside of your car class. So when you want to implement it, and it's like I said, it's just a quirk of Java. That if you have a class inside of another class, that's what they call a static, what they call an inner class, then you need to use that static keyword. But then you can use this class just like you would, for anything. As you can see here, I've created this new bike, but it's a car.bike because this bike class is inside of the car class. Does that answer your question?
Yeah. And I mean, I just made it as a new file. Everything magically works. So I mean, I'll probably just go forward with that approach. But I appreciate the walkthrough.
Yeah, I mean, it's definitely the most preferred method to have every every class inside of its own independent file for compilation reasons mostly, but also it doesn't make sense, logically thinking, it doesn't make sense to have property inside of project 4. You know, what if sometime later you want to use that property class in a completely different project, right? Should you recreate the property class completely? No, you should use the one you already wrote in its own independent file. Anything else? And thank you to Corey who told me how to fix my audio. Yes, Mike. Any questions you have for any of the projects, just email me directly. I'm usually pretty quick about getting it back to you. And keep in mind, Tuesday, 11:30 p.m. Eastern Standard Time is the cutoff for anything to be submitted. So if you email me, you know, at like 10 o'clock on Tuesday night, I'm probably already going to be in bed. So if you do have questions that you like answered, you know, early and often is definitely preferred. But you definitely email questions about anything you may have. All right, Corey, it looks like you're the last man standing. Do you have any questions?
No, I don't have anything right now. I was just kind of hanging out to see if anybody else had anything that they were saying. Um, my internet crapped out halfway through, so there's some stuff that you probably went over that I'll just have to look later when you upload the video.
Okay, yeah, I'll have the video online probably in an hour or so, and then I'll email out the link. If you have any questions, you know, after that, just email me directly, and I'll get back to you as soon as I can.
Okay. Thank you very much for doing this.
All right, you're welcome. Have a good day.
You too.